on people. And on the international side, somewhat of a similar thing happened, but there was more pressure for some of the health impacts. So the IPCC, the Intergovernmental Panel on Climate Change, aggregates, most of you know this, aggregates what we know on the physical aspects of climate change, about impacts, about vulnerabilities, and how do we adapt to the climate change that we're committed to, and about the magnitude and rate of change, so looking at mitigation options. The IPCC assessments since the 1990s have showed climate is warming. Humans are responsible for most of the cause of most of the observed changes, and that increasingly the health of people and ecosystems are tied with the changes. So more recently, the IPCC has focused on the threat of climate change to achieving the UN's goals for sustainable development goals. And that's really key to most of the people in the world. In its most recent assessment, IPCC devotes an entire chapter to the social aspects of mitigation, meaning that the social science and behavioral sciences are now robust enough to include in the assessment. And that's really important because it changes the narrative a lot. About a decade ago, I worked for the Obama administration in the White House. I was a deputy to the president's science advisor overseeing energy and environment. And one of the interagency committees that I co-chaired was one that focused on the climate program, but was looking at environment and natural resources. And we included sustainability in the focus of that committee across the government, with the notion that we weren't just looking at research and development for natural resources and environment, but looking at sustainability outcomes and how does that research program address those outcomes. So that's really important. And if you look at where we are now, we are actually more focused on climate change and effects on people. And between understanding the systems of environmental change, the sources of environmental change, to the effects on people, communities, and sustainable outcomes. So the research that is the focus of this panel is at the forefront of much of this work and about the changing narrative of climate, health, and sustainability. So first, we're going to hear from Scott Miller, and who has to run off and teach a class. So we're going to get him really engaged quickly. So, and each of you is going to introduce. Oh, okay.
Should I go more here?
Yeah.
Great. So I'm Scott Miller. I'm an assistant professor in environmental health and engineering department. And in my group, we study greenhouse gas emissions. Where are they coming from? Who's responsible for those emissions? Are they natural or human caused? And we look at anything from local scale, like the scale of an individual city, up to global scale, covering all the different continents. Do we want to do the Q&A?
You were going to introduce or you want me to do the questions?
Oh, yeah. Oh, sorry, we're
okay. You want to kind of tee it up a little, and then we can do it.
Yeah, that sounds great. And so I think one thing that's kind of emerging from our particular area of work is that greenhouse gas emissions are often kind of a lot different from what we might have assumed. I think that, both when we look at CO2 emissions and other greenhouse gases like methane, sometimes what we find is that, a large fraction of emissions are coming from a relatively small number of bad actors. And so figuring out who these bad actors are and how to quantify those emissions is really, really important. And then I think another thing that's been really transformational lately in our field is the increasing use of remote sensing data or satellites that can really give us global scale perspective. Because there are some countries in the world that do a relatively good job of monitoring the greenhouse gas emissions. So for example, in the US, we have about 30 surface observations across the US for monitoring emissions, but there are other countries in the globe that have essentially no surface monitoring stations and don't really have an interest in putting together any kind of monitoring stations. And so I think in terms of climate and sustainability, a challenge kind of moving forward in the future is figuring out effective ways of gauging whether or not countries are meeting their commitments to reducing their greenhouse gas emissions and going beyond just the official numbers that these governments are reporting to the United Nations, but also coming up with independent ways of evaluating that information.
So how accurate are these emissions estimates?
Yeah, that's a great question. So the way that most countries put together greenhouse gas emissions estimates is by putting together what we call a greenhouse gas emissions inventory. So to inventory emissions, you might say, if you want to know emissions from cars, you would count up the number of cars on the road, you get some statistics on, what we think the average fuel efficiency is for the fleet of cars in the United States, or, the fuel efficiency for individual models, and figure out how many of each model was being sold, and then kind of do an accounting exercise and multiply those numbers together and add them up, and then overall come up with estimate for total greenhouse gas emissions from cars. And so you can imagine that this can get to be quite an extensive accounting operation, because not only are cars emitting greenhouse gas emissions, but there are a whole slew of different sources across the United States, and both the data that you need to understand how much of this process is happening, so we call this activity data. That's all going to come from different sources depending on what you're dealing with. If you're dealing with cars or agriculture or power plants, and then also getting what we call emissions factors. So understanding, for each mile that a car drives, what on average is being emitted. That kind of data comes from a lot of different places as well.
And maybe I'll ask one question, maybe somebody in the audience will follow up. But one of the questions that comes to mind is that we focus on for sustainability. We say, well, cities are the answer to trying to achieve some of these objectives. If that is the case, then how do we think about emissions from cities, and is that the way to go? I mean, should we really be focused on moving into cities and reduce our footprint?
Yeah, I mean, I think this might be a slightly different answer than what you're getting at, but I'll get to that in just a moment. I think that something like 80 or 85% of the American population lives in what's considered a city or an urban area, and so if you want to understand greenhouse gas emissions, looking at cities is a really important place to look. And many faculty here in this room are part of a Department of Energy project, particularly to look at, Baltimore as an urban laboratory. And interestingly, NIST, the National Institute of Standards and Technologies, has made Baltimore and Washington, D.C. their sort of case study to develop a way to monitor emissions from cities, and then hopefully expand that approach across the United States. But overall, in terms of greenhouse gas emissions, people who dwell in cities tend to have lower emissions because we live in more compact housing, tend to drive cars less, fewer miles, or use public transportation more often.
Questions?
Yeah.
Okay. Yes, please. You mentioned that there were a few bad actors. Could you tell us who they are?
Yeah, that's a really great question. So, in terms of, I'll give the example of cars. I don't know if you've ever driven down the street and seen like a clunker in front of you that is, spewing out black smoke coming from the tailpipe of the car. It turns out that, those sorts of clunkers produce a disproportionate amount of CO2 emissions. One thing that a lot of scientists have been focusing on lately is methane. So the second most important greenhouse gas. A lot of methane so a lot of CO2 is emitted from combustion, from burning fuel and creating energy that we all use, whether driving a car or electricity. Methane tends to be like a byproduct, right? And kind of an unintentional byproduct, like cows are burping methane, and that methane depends on what kind of food that they eat. And then also the natural gas sector, natural gas is mostly made out of methane, and that natural gas can leak, if there's a broken pipe or natural gas is not drilled from the ground in a very careful way. And I think one of the biggest areas where we're seeing these bad actors is methane emissions, particularly from the natural gas sector. Like people think that something like 50% of methane emissions from the natural gas sector are coming from something like 5% of oil and gas facilities. So facilities where maybe a pipe is broken and nobody's quite noticed that something is broken and spewing methane, right? Because methane is clear, it's odorless. And so coming up with effective monitoring systems to figure out, okay, who are those bad actors? What wells are not functioning correctly? And then detecting that quickly and taking action to remedy that problem, I think is really important. Right. And that's also lost product for oil and gas companies as well. Yeah.
You mentioned the methane, particularly like in the gas industry, about the abandoned wells. Is that something that would be relatively negligible compared to some large scale operation, or the aggregation of abandoned wells? That's also.
Yeah, abandoned wells have been a huge topic lately, and that's actually a specialty of my friend Mary King. She's at McGill University up in Montreal, and she went around the state of Pennsylvania looking at methane emissions from abandoned wells. It turns out it's incredibly difficult even to find these abandoned wells because they're not tabulated, they're not documented. The way that she found a lot of these wells is she would go knock on farmers' doors and say, hey, do you happen to have any abandoned wells that you know of on your property? Or would go to like community centers to community events like bingo night at the Senior Citizen Center in small towns across Pennsylvania and ask people, hey, does anyone here know of abandoned wells? And people would say like, oh yeah, like in the trees behind in the back of the farm, like there are a couple wells back there. And that was the best way of finding these abandoned wells. I think that the total amount that's leaking from those wells is still quite a bit less than the total amount coming from active operations in places like Pennsylvania. But a lot of those wells are not properly capped. They're just open and releasing methane into the atmosphere.
Question about the accounting that may make things easier. You lose some of the granularity in terms of vehicle type and all that stuff, but can you just use gasoline sales and diesel sales and just say 99% of this or 99.9% of the carbon embodied in the fuel is going to get burned?
Yeah.
And compare that to the more detailed.
Yeah, and I think that's another approach, say, for estimating CO2 emissions from cars. It turns out that cars are probably one of the areas of emissions that we know the best. But I'll give an example of something that's way more challenging to quantify, and that's, for example, methane that's coming from agricultural operations. So that depends on climate. It depends on what the cows are eating. It also depends. It turns out there's a lot of methane that comes from cow manure, from cow poop, and so it also depends on what the farmer does with it. And so what places like EPA do is they just come up with a ballpark estimate, like, okay, in Missouri, we think that 50% of the farmers are spreading the manure across their fields, and maybe another 20% are putting them in tanks, and another 10% have lagoon ponds, and they come up with these different estimates for each state. But all in all, for agriculture, we find that we measure methane levels in the atmosphere, that the amount that we're seeing in agricultural regions is about twice what EPA says. So there's some disconnect there, and we don't quite know what it is. And no one's in the past 10 years nobody's figured out what's causing that disconnect.
Okay.
Well, thanks, Sherry.
So next up, I think Darryn. With you, you're not going to do slide, right?
I've got slides, but that was, you went, I don't know if they're on here. Let's see. No, I'm not on the energy panel. 30. So do I have to share a screen or something?
Yeah.
So I'm Darryn Waugh. I'm a professor in Earth and Planetary Sciences in the School of Arts and Sciences. I've been at Hopkins 25 years. And for most of that,
I was doing research on large scale atmosphere and ocean kind of processes. But in the last kind of 5 to 10 years, a lot of my research has moved towards looking at urban heat and kind of air quality. And a lot of this has been driven by collaborations with Ben Zychek, colleagues in engineering, and colleagues at the School of Public Health. And a lot of undergraduates have done lots of the kind of research. And so the area that I was hoping to chat about today is following on from, we've just heard about greenhouse gases increasing. I think you all know that that causes the climate to change and the climate warming. And one place where we're going to feel that the most is in cities, because cities are warmer than the surroundings because of a process called the urban heat island. And so if you're looking at when the extreme heat is going to be occurring the most, if the cities are warmer than the surroundings, the cities is where we think the heat will be hotter. And so if we're worrying about the impacts, it's looking in the cities where we also all live. And I guess so this is a map, I should say, this is a satellite image that shows the heat from Baltimore. It's actually the land surface temperature. And you can see the hotter colors are in the middle rather than the exterior. But rather than the urban heat island, it's kind of probably better to think about cities in terms of a heat archipelago. And as you all know, if you drive around Baltimore, so the heat island is because the cities are built up and there's not grass, there's more buildings that maintain the heat, less vegetation cools, less shading. So that's why the cities are warmer than the surroundings. But within a city, there's variation. You have remnant forests, there's parks. So it goes from areas where it's all concrete, hard to find a tree, to other areas where it looks like a little kind of forest. And that causes the temperature to vary. And so the images at the bottom, the one on the left was the heat, the one on the right is an image of the amount of development. And so the redder areas are the areas that are warmer, have more development, and are also the areas that are hotter. And so we're trying to kind of understand this and its potential kind of impacts. Okay, okay. And so this would be an issue we'd want to kind of understand on its own, just to have a feel for how the heat kind of varies within the city, but it's kind of compounded by the fact that not only is the heat in the city not evenly distributed, the vulnerability, the people who live in the city, the vulnerability of heat is also not evenly distributed. And so I think you've seen this probably already today, versions of this, I can't see the top thing. So what's been covered is what's known as the Baltimore kind of black butterfly. And these are images. So the one on the left is showing percentage African American population. The one in the middle is showing the percentage of poverty living below the poverty line. And the one on the right showing a life expectancy. And the point is, it's not evenly distributed across. And so there's the east and west of the city, the regions, there's kind of the wings of the butterfly, and sometimes there's a white L that's in the middle where there's a higher income, a higher percentage of white, and a longer life expectancy. And so if you're poor and it becomes hot, you're less likely to have an air conditioner or less likely to be able to respond. You also probably have underlying health conditions because of your other healthcare system, etc. So you're going to be more vulnerable to increased heat. So we need to understand how the heat is varying and where is it more. So which areas are hotter and where are the more vulnerable populations. So in terms of our research, one of the things we heard about, Scott was talking about satellites, and I've shown you some satellite images. We've actually gone low tech. And low tech in the sense, it turns out that the National Weather Service measures the temperature in one location in Baltimore City. And actually wasn't working for 2 years. The major weather information we get comes from BWI. And so we can have a satellite view of the land surface, but that doesn't tell us what the surface temperature is like. So over the last, well, several years, we've been using a small kind of 5-button sensor the size of this that records the temperature. We've been putting students, undergraduate students, to good use. This is a good photo. A former graduate student who Ben and I took a photo of her standing on a bike to reach high up on a tree, which wasn't the most safe thing. So we'll stick to this. There is a step ladder there, and there's a member of the community, another Hopkins professor in the background, watching the students do the work. And we've been putting these around the city, trying to kind of measure how the temperature varies. And we're doing this changes, but last summer we had some to get the large scale variation. And then we put a couple of populations in Broadway East and Old Goucher. Old Goucher's just south of here. These are two neighborhoods where we're working with the community. So we're trying to determine how much the temperature varied within there. And long story short, it's complicated. So given this and using some statistical model, we can get a map of how the temperature varies throughout the city. Then you can see there's Patterson Park is there. You can see Green Mountain Cemetery, so you can see the green spots buried in there, but you can see the city near the inner harbor is warmer than the surroundings. And this figure here, which is either simplifying things or making things too complicated, you can't tell what's going on. I don't know. It's trying to combine the temperature with some measure of the vulnerability. This is social vulnerability index. And so the key table down here, and the key point of these regions that are in not the darkest, make it this reddish color, are regions that have high vulnerability and have high temperature. So the temperature and the vulnerability don't match up exactly, but it turns out that there's the regions that to the east and west of the downtown city are regions which have high temperature and have high vulnerability. So this is kind of the starting mapping, and we're going to be using this data, and we are using this data for a whole kind of series of projects. I'm just listing some of them here. So we're trying to understand. So I'm a atmospheric scientist. So at the start, I want to understand what causes these spatial temporal variations in the heat, in temperature and humidity. But we're also working with colleagues from the School of Public Health and School of Medicine to try and combine this high resolution heat data with asthma data records that we have from the hospital to determine kind of what's the relationship, how much does cases of asthma go up with increased heat. We're also, if students are looking at kind of we're wanting to come up with a solution. So there's various solutions to reduce the heat. And so we're trying to kind of quantify how effective planting trees would be in the long term, or putting up different types of shading, or putting a cool pavement on the surface. So we're working on coming up with estimates of that. And then once we've got the heat health relationships, the effectiveness of various interventions, we're going to be feeding these into decision support tools to come up and to kind of optimize, to define kind of what are planning strategies, how effective will they be, and do these match with what the communities who are affected by it, what they want. So it's a kind of iterative approach. And also at the same time, we're starting to think about the relationship with air quality. And so there's similar issues about air quality varying across the city, impacting the health. And we know even less about how air quality varies within the city than we do for temperature. So that's where we are. Any questions?
So what I would suggest is that
I'll wait till the
if there are any questions of clarification, if you could ask now, and then otherwise we'll hold the other questions to the end. Okay, go ahead.
So you had that graph showing the different temperatures that you had found.
Yeah.
On the map. Some were like right beside each other, but a different color.
yeah.
How different were those temperatures?
So
Like, or maybe like the most like striking difference.
they can be up in degrees Celsius, but so we're putting them in the business on the tree. So we're trying to figure out what causes that small variation.
So you have seen like neighborhoods right beside each other be a few
Or
degrees.
within a neighborhood, you can see differences, yes.
A few degrees Celsius.
Where, yeah, 1 degree Celsius, we're trying to isolate with that because it's a different neighborhood. We actually put all these buttons in trees. So some of the difference could be because one's a bigger tree than a smaller tree. So there are differences that we're trying to sort out.
Okay, so we.
Sorry, T-Max, how long do you have these things up in trees, multiple days?
Yeah,
Is
also.
that max of max?
No, so T-max was the maximum, sorry. T-max is the maximum temperature each day.
Got it,
And then that was the average over the whole summer. Sorry, I should have explained that.
thanks.
Okay, so now we've done greenhouse gas emissions, heat effects, and now Jaime Madrigano is going to talk a little bit about overall health effects of impacts of climate change.
Well, let's stop sharing.
First,
Here we go. You got, I don't know how this screen share, we see how to do that.
download it to the computer,
Ah,
and then open it.
Did you see Zoom on?
I think this is it. This is it.
It's not screen sharing now.
Oh.
Okay, I think that's. Okay, all right. Hi, everyone. I'm Jaime Madrigano. I'm a faculty at the School of Public Health, and I study broadly the health impacts of climate change. More specifically, I have studied the health impacts of extreme heat and also air quality. But so today is just I think we were going to have a little bit of a discussion, but I'll just kind of just open up with some broad points just to kind of set the stage. First, I just wanted to say that there are really a myriad of health impacts from climate change. And we can kind of think about them, this is a graphic from the Centers for Disease Control and Prevention. And I think it's a really nice way to visualize kind of all, and not all, it's not comprehensive, but many of the different health impacts that we know are occurring with climate change. So you can kind of see that sort of the middle of the center circle really is talking about the phenomena, the meteorological phenomena associated with climate change. And then kind of branching out from there, you get, with rising temperatures, we have changes in episodes of extreme heat. So we have the changes in weather phenomena. We have more severe weather events that occur. We have increases in allergens and air pollution. And then from those kind of discrete events, we can think about, there are many different health impacts associated with them. So extreme heat, we have things like more occurrences of heat stroke, but also we tend to see exacerbations of respiratory disease and cardiovascular disease. When we have a severe hurricane or flood, we might see health impacts from mold exposure, or we might see mental health impacts from people being displaced from their homes. So there's just a lot of, quite a range, and certainly not everything is listed on this slide, but this gives you, some example of some of the different types of things we see associated with these weather phenomena. How we kind of study these things, we really, most of the time, when we talk about the health impacts of climate change, we're actually talking about the health impacts of extreme weather. There is some work to kind of do attribution studies of longer term climate change and teasing out the differences in health that we see over time, but most of the work in the health field, at least, is actually looking at historical extreme weather, health impacts associated with that. So, for example, a heat wave event or a hurricane event, and then because we know these weather phenomena are changing, we know that heat waves, for example, are becoming more frequent. The heat wave season is lasting longer. That's been happening over the last several decades. We can then infer that these, health impacts are growing more and more frequent and more severe over time. There's also a lot of work that we do in this field to think about who is most at risk for the sustaining the health impacts of related to extreme weather and climate change, and it's definitely kind of overlapping with a lot of what Darryn was getting into. But this is from the U.S. Global Change Research Program. I think this is a figure I use a lot, but I think it really calls our attention to sort of the three things we tend to think about when we think about what increases our vulnerability to these extreme weather events. Something that may increase someone's exposure. So again, if we think about the extreme heat example, and Darryn mentioned how within a neighborhood or within a city, you might have a much hotter place because of lack of trees or more blacktop or other characteristics of the physical environment that might increase someone's exposure to higher temperature, on any given day than their counterpart living across town. Sensitivity, can be related to things like someone's age. We know generally for many health outcomes, but those related to extreme weather, the very old and the very young tend to be a little bit more sensitive. People with underlying health conditions, perhaps because of the medications they're taking, which help them, which interfere with their thermal regulation in their body, that may impact how sensitive they are to extreme heat. And then things like adaptive capacity, often we're thinking about the resources people have to either escape that exposure or protect themselves from it. So you could think of things like air conditioner, which often is, due to financial constraints, people can't afford to run air conditioning in the summer, or they might not have access to it. So all of these things together really kind of increase vulnerability to these extreme weather events. And we can, in the public health field, using tools in epidemiology, we can kind of look at these different factors and try to tease out, who are the populations that are most vulnerable. Just an example of some work I did quite a while ago, looking at extreme heat in New York City, and we did a big epidemiology study where we looked at all the deaths that occurred in New York City over a 10-year period, and then looked at the factors that were most common in the people that were dying on those extreme heat days. And those factors are the ones I have listed on the left of this slide. We kind of combined those factors and saw where they were most prevalent within the city and created an index to kind of then geographically target what neighborhoods were most heat vulnerable based on where people were dying during those heat wave days. And you can kind of see this is basically the risk of dying during an extreme heat event within New York City during that time period. And so your risk is kind of relatively low if you're sort of in the areas that we define as the first quintile, which is the blue areas on the map, and your risk is much higher if you're living in one of those red areas on the map, which is our fifth quintile. And that's because a lot of these vulnerability factors that contribute to within this population dying during the heat wave are sort of clustered in these neighborhoods. Now, those factors are things like which I showed on the previous slide, things like race, we found that Black New Yorkers were more likely to die than other race and ethnic groups in New York. We found that individuals living in poor neighborhoods were more likely to die than individuals living in wealthier neighborhoods. And there's a lot of reasons these factors tend to cluster together. They are also areas that tend to be hotter, as Darryn mentioned, because they have less trees and more blacktop. And so I wanted to just mention this historical context, which I'm sure many people are aware of. This is a map of Baltimore. So this looks very similar to the maps Darryn was showing. And it kind of just provides a little bit of historical context on why our cities, one of the many reasons that our cities look the way they do. So this is a map of a practice that was called redlining, occurred in the 1930s, where there was discriminatory lending that was kind of codified. And so particular neighborhoods received less investment, and this kind of resulted in decades and generations of disinvestment in certain neighborhoods, more investment in other neighborhoods. So again, we mirror those maps that Darryn showed, where we some of the outer areas which are wealthier, have more trees, are still cooler to this day than some of the neighborhoods in the more central part of the city. This is just to show you, it's not the best picture, but this is an online tool that you can access that kind of compares environmental characteristics. So on the left is the percent of tree canopy cover, which we know contributes to cooling in cities. And on the right is that historical redlining map, right? So we can see those areas that were sort of disinvested in the red areas in the center have the fewest amount of tree cover today. So that's just, I think, something to think about when we're thinking about climate adaptation solutions and we're thinking about improving health in these neighborhoods. All of these things are connected, and we sort of have to think holistically about the solutions and the root causes of some of these problems. And this is just from some other work I've done, thinking about greening solutions, and how we might think we're doing a good thing, but there are potentially unintended consequences of actions. So we could plant more trees and we can green neighborhoods, but sometimes that can spark concern in communities about being displaced or about neighborhoods changing over time. And this is from some work done in partnership with an environmental justice organization, where they've been hearing these fears from their constituents over the time they've been working on climate adaptation solutions. So it's really important to kind of work in partnership with the residents that are living in these communities to kind of understand what solutions are preferred by residents and how to implement them in ways to kind of avoid unintended consequences. So I'll stop there.
Okay. Any questions of clarification before we move on? Okay, so now we've gone greenhouse gases to heat and impact on health. And we're going to drill down into Smith Island and Chesapeake to look at some of the social, anthropological, ecological implications of climate change. And Jana,
you want to say mine? No, I can say mine. Yes. Good afternoon. My name is Jana Kopelent Rehak, and I'm not new to Hopkins, but I'm new to position in Urban Planetary Science Department. I'm a teaching faculty in environmental program, and the first class that I've been teaching for the program this semester is in sustainability. So this conference is very relevant to my class, to my being at Hopkins. And my research is rooted in social sciences, anthropology. So I will show you a couple of slides of my work that I have done last 10 years. In fact, which result is coming out soon in the fall. I'll have a book with Hopkins Press about a community that lives on a small island in Chesapeake Bay called Smith Island. And so while I do ethnographic study that's very strongly focused on qualitative research, I also link that one location to global islands. Island as a place, as a type of geography, is the most vulnerable to climate change from all places. It's also so affected by flooding, often extreme heat, extreme weather. Island people are very vulnerable, yet there are ones that are typically the most intimately connected to their places through their kinship ties, so social organization, but also growing up and being in an island community. Thank you so much. It's very personal and very intimate. And so when this environment is changing, rapidly changing, and changing to point of loss, like loss of land and erosion, for people who occupy or who inhabit islands is closely connected to loss of their sense of identity. And so this is not far away from us. It's a 3-hour drive. You can see on the map. Crestfield is the town where I drive with my car and by boat. In about an hour, I'm on Smith Island in Chesapeake Bay, which is the lower part of Chesapeake Bay. And this is a Smith Island with 3 communities. You could see small villages on the island. Island has been occupied since 1800s by British, Welsh, Cornish settlers who started farming originally, actually, and it was not until 19th century that they transitioned to water economy, oystering and crabbing on the water. You could see here also how this is very much grasslands. And so yesterday or 2 days ago, Darryn and I had this conversation that heat between contrast between city and places like this, and Darryn said, oh, there must be wind, it's out in the open. But no, it's not actually the case. I said it's a grassland, so there's a sense of track and it's very hot and humid and foggy. So it's a very difficult environment, yet people stay. And in spite of difficulties, environmental difficulties, they stay. And so I was curious why. For us outsiders, it's easy to say, oh, people can just move on. Island is eroding, population is declining. Why would you just move on? So as an anthropologist, I have been investigating why would people stay in a place like this. And so I'll give you a couple ideas or hints about why people stay. So you could see this is one of the major newest villages. The one on the top is the oldest one connected by road, and then separate village from some separate agriculture is Waugh, Rosewood, Carrollton. All actually to insiders, they all have each separate slight identity. They have very particular language. Some linguists argue that Elizabethan Shakespearean English has been said that yes, but it's also a community on the island that has its own isolational language, and then some southern accent as well. As I mentioned, they work on the water, so for them, water is sense of sustainability, but water is also what is their problem. So you could see slides on the far left. That's from last fall. I have been on this island since 2013, regularly visiting, staying, and have to say that when I started this work, prediction was, on 50 years, something is going to be very different. I have seen it in last 3 or 4 years. Things are changing much faster in terms of flooding, massive flooding and erosion. It is predominantly aging population. And so a lot of people of mid and young generation are gone. And so most of the people on the island are in their 70s, 80s. And you could see this, one of the signs on the right is ghost trees, so-called. So trees are uprooted. Trees are the ones that are dying quite quickly. You could see that they're symbol of a rapidly changing environment. On the left middle here is erosion of the land. So land is being eroded from northwest part of the island. And this is one of the extreme days. So island has always been having flooding season, but typically month in the spring, month in the fall. That flooding season has been expanding. And so much longer flooding season is making land basically not fertile. So you can't do a garden, you can't grow anything. And people who are there now do remember a time when they had orchards, where they had gardens. So they're, in terms of food sustainability, they're completely dependent on the mainland, food from the mainland. And the food they're getting from Chesapeake Bay, which is oysters and crabs, are for commercial purposes. So they don't really sustain themselves with that. One of the ways that they manage their land, and by the way, managing land is there from the beginning. So first settlers that came to the island, before they built their homes on a piece of land, they created so-called ditches, elevations that protected their land, not just homes, but their land from water rise. So there is built into Smith Island way of thinking about land is to manage the land. So they, for example, say, keeping up with the waterfront. That's part of being everyday kind of care. And the other way is also building channels. So you can see here, it's a zero elevation, and there's a rain, and there's high tide. Also water coming from below, so it's sheet effect. Gets immediately flooded. It's demobilized. People can't move freely on the island, which is very scary when you think about aging and health, especially women outlive men on the island. So there's more women than men, and so they live alone in the house. And when there is a flooding, they become prisoners of their homes. So it's mentally very challenging, difficult. As people are aging, they have to go to the doctors more often. And so getting off of the island, going to mainland is becoming more and more difficult, because if there is that particular day flooding, they can't get to the boat. So they manage by these channels. They manage by elevating roads. Right now, they have a big grant from the state to elevate all the roads so they can move through it. But they also have these so-called dry decks, buffers that have been built around the island, physical walls from stones, just pile stones to protect erosion. These are some of the people that I worked with. More than half of them are actually gone by now. But they do live life, because I would say partially medical care they have access to. And so it's an interesting place to be. Managing, this losing land to the water, but also one's own health. Many of these people would not prefer to live like life as like they are, because their grandparents died much younger. And so they're facing two new kind of deaths or two new kind of situations. Manage their health in a late life and manage their land that they're losing control over their own bodies in some ways and their own island. So it's a very complicated and stressful situation. And so since we're talking about environment and health, I want to say that one of the things, so I've done this research based on ethnographic interviews, based on being there, talking to people, listening about their history, about the time now. I'm interested in their experiences. It's very deeply rooted in the story they have to tell. Of course, there are multiple stories. They tell story to outsiders, different stories going on in. But one thing that they always talk about is their health. So in contrast to mainland, health is not just subjective. They would talk about their health in a great detail in the public places to strangers. It's part of conversations. And so when you're ill in a small island community, your illness, your health is always concerned, not just yours, but the community as well. So that has been my interesting discovery that health is very much something people will talk about publicly, much more than climate change. They will not talk about climate change because if they do say very openly, there is such thing as a climate change, they will, it's a very risky subject because there will be possibility to say, well, you don't have a future, so we'll close you down. And we had this conversation with Jaime that, today Island is not an independent entity like it was in the past. Island is completely dependent on services, or very dependent on services from state, from government, connected, there's a flow. And that's true about global islands in general. And so they don't have power over staying. If government decides to shut them down and cut out services, they would have to go. And so that fear, it's stressful mentally, but also it's something that creates a silence about climate change. I would say one thing that if I could argue for what Smith Islanders need the most is, and that's something that they have been selected to be part of government program to start telemedicine. And this happened